Yeah, hello everyone. So in this video, again, I am going to continue some more problems based on this C-R equation and differentiability. So first problem, you are looking on your screen, fz equal to z conjugate square by z if z is not equal to 0 and z equal to 0, then 0. So in this question, actually we have to prove that C-R equation satisfied. Here you are looking here, we have to prove that here z equal to 0 is given 0. So in this question, actually we have to prove that C-R equation satisfied. C-R equation means Cauchy-Riemann equation. Cauchy-Riemann equations satisfied, but function is not differentiable. So this we have to prove in this problem. C-R equation satisfied at z equal to 0, but function is not differentiable. So let's calculate what is real part and what is imaginary part of this function, and then we can apply concept of partial derivative. So f of z is given here. Z conjugate, we know that z conjugate is x minus iy, and here square is given. So this is square and divided by x plus iy. So here, are you able to separate the real and imaginary part? No, because once if you are getting imaginary in denominator, so that function actually you have to multiply with conjugate so that this I it can be made free from denominator. If you are getting I here in denominator, means you are not able to separate real and imaginary part. So better you multiply with conjugate. So we can write here x minus iy and divided by x minus iy. So this equal to x minus iota of y. This will be what? Whole cube and divided by a plus b, a minus b. So you will get a square minus b square, but because of I square value minus 1, so we can get here x square plus y square. So now you are able to separate real and imaginary part because now I is removed from denominator. So what will be its real and imaginary part? You can apply a cube minus b cube whole cube. So real part of this function. So real part of this function, you can calculate u of xy. This you will get x cube minus 3xy square minus 3xy square and divided by x square plus y square, and imaginary part v of xy, imaginary part v of xy, you will get y cube minus 3x square y minus 3x square y by x square plus y square. How you will get? Simply you can apply here a cube. So you will get x cube. We are getting here, and minus b cube. So minus b cube is what? I cube. I cube, we know that I square is minus 1. So you will get plus I into y cube. So because of that, here we are getting plus y cube minus 3ab, a plus b. So we can calculate real and imaginary part of this function. So now we have to prove that C-R equation satisfied means at origin. So you have to prove that here dou u by dou x at 0 comma 0, and this must be equal to what? Dou v by dou y at 0 comma 0. And second CR equation also we know that dou u by dou y at 0 comma 0, this must be equal to minus dou v by dou x at 0 comma 0. So easily we can calculate. Again, you can ask whether in this question we have to calculate partial derivative by differentiating or by using that formula. So again, if you will observe here, u00 is not defined. Even if you will differentiate this function with respect to x, again you will get again 0 by 0 in derivative also. Similarly, for vxy also you will get v00 is 0 by 0, and derivative also you will get 0 by 0. So better we can calculate by using the formula of derivative. So what was dou u by dou x? I hope you remember. Dou u by dou x is what? At 0 comma 0 means a and b are 0 0. A and B are 0, 0. So this equal to limit S tends to 0. S tends to 0 and U value is, you can write here, U H comma 0 minus U 0, 0 and divided by H. So this equal to limit S tends to 0. UH comma 0 means what? X component H and Y component 0. So you will get H cube minus 0. H cube by H square. So you will get H only because denominator H square. So this we can get H and minus 0 by H, which is equal to what? 1. Again, you can observe here how I have taken U 0, 0, 0. Because Z equal to 0 means what? Z equal to 0, once again I want to remind you. Z equal to 0 means what? If I am going to ask you what is real part of this 0 and what is imaginary part, then you will answer real part is also 0. So here real part of this function, if I assume U of xy, this is also 0 and V of xy also 0. So at 0 comma 0 you will get 0. So I hope now this concept is clear to us. Z equal to 0 we have to use. Otherwise, what is use of this Z equal to 0? This also you can think. Z equal to 0. 0 means what is use of this Z equal to 0? They can ask simply this question, Z square by Z, and Z is not equal to 0. So because of that, you are not able to calculate directly U 0, 0. We have to calculate by second function Z0 is 0. Similarly, let me calculate dou u by dou y. What will be dou u by dou y at 0 comma 0? Dou u by dou y formula, I hope you remember, limit k tends to 0 and u of 0 comma k minus u 0, 0 and this divided by k. So this equal to what will be u 0 k? Again, you can calculate u 0 k is what? U 0 k means x component 0. And here y component is k, but here because this x is multiplied, so this will be what? 0, 0. So this you can get limit k tends to 0, 0 minus 0 by k. And this equal to what? 0. Yeah, I have explained many times this is not 0 by 0 because numerator is exactly 0. You just keep in mind when we are going to apply concept of L'Hospital rule. So numerator and denominator both should be tending to 0. This is if anyone is exactly 0, if numerator is exactly 0, then answer will be 0. If denominator is exactly 0, then answer will be infinite. So because when we are going to apply this limit, before applying this limit, this resultant is what? 0. So finally, you can apply limit k tends to 0 into 0. So this you will get 0. Similarly, what will be dou v by dou y? This you can calculate. So dou v by dou x will be what? Dou v by dou x. Dou v by dou x at 0 comma 0. This will be what? Limit h tends to 0. V of h comma 0 minus v 0, 0 and divided by k. Sorry, divided by h because we are differentiating with respect to x. So here h and k both are changing along x direction. So this is only different name. Along x we are giving name h and along y-axis we are giving name k. So this is what h. So what will be value of vh comma 0? Vh comma 0 is what? This is v. H comma 0 means x component h and y component 0. So here y component 0, here also y component 0. So what you will get? This equal to limit h tends to 0, 0 minus 0 by h. This equal to 0. What will be dou v by dou y? Dou v by dou y at 0 comma 0. This will be what? Limit k tends to 0, v 0 comma k minus v 0, 0 and divided by k. So v0 comma k will be what? 0 comma k. v0 means x component 0, y component k. So here k cube by k square. You will get here k cube and divided by k square. So this will be also 1. So this will be also 1. So dou u by dou x, dou u by dou x, what was CR equation? Dou u by dou x at 0 comma 0. Dou u by dou x 0 comma 0 we are getting 1, and dou v by dou y also you are getting 1. And second component dou u by dou y also we are getting 0, dou v by dou x also we are getting 0. So CR equation satisfied. Now how to check differentiability of this function? Here I will explain because I have noted down 3 more problems. So here I will discuss. F dash z naught, how to check differentiability of a function? F dash z naught equal to limit z tends to z naught and f of z minus f of z naught and divided by z minus z naught. So here z naught value is 0. So limit z tends to 0, z tending to 0, f of z is what given? Z conjugate square, z conjugate square by 1 minute. Fz, this is what? Z conjugate square, z conjugate square by z minus f0 is given 0. So this is 0 and divided by z minus 0. So finally you will get limit. Now we can assume z tending to 0 means x is also tending to 0. Y is also tending to 0. Z conjugate is nothing but what? X minus iy whole square and divided by x plus iy whole square. So this, if this limit will exist, we can say function is differentiable, otherwise function is not differentiable. So simple, you can take along x-axis. If I will choose path along x-axis, y should be what? 0. So this you will get limit x tends to 0. Now y 0 means you will get x square by x square, x square by x square, which is equal to 1. Similarly, you can choose path along y equal to x. Second path you can choose along y equal to x. Then what you will get? X minus ix. So here when you will take y equal to x, so x is common from numerator and denominator, and you can cancel out. So this you will get limit x tends to 0, x tends to 0, x square by x square. So numerator you will get 1 minus I whole square, 1 minus I whole square by 1 plus I whole square. This equal to a square plus b square minus 2ab. So you will get here minus 2i and denominator a square plus b square plus 2i. So 2i cancel out. So this time you will get limit minus 1. So 1 and minus 1 both are different. So we can ensure that this function is not differentiable at z equal to 0 because we are getting different limit along different path. So if function is not differentiable, then we cannot talk about analyticity of any function. The second problem is also similar to first one. Yeah, this only in quickly I will explain. If I will ask what is real part of this function, so real part of u of this function is what? Second problem. U of x y is what? If you will multiply by x, so you will get x cube into y power 5 and divided by x power 4 plus y power 10. And imaginary part b of x y, b of x y will be what? You can multiply x square into x cube. So when you will multiply in the second component, so you will get x square into y power 6 and divided by x power 4 plus y power 10. So again, same formula you can apply, dou u by dou x and dou u by dou y. You can calculate this will come out to be 0, but I will explain. So dou u by dou x will be what? Dou u by dou x at 0 comma 0. Dou u by dou x at 0 comma 0 limit s tends to 0. U of h comma 0. U of h comma 0 minus u 0 0 and whole divided by h. So u h comma 0, because here both the function is given in multiplication form. So this 0 minus 0 by 0. So this you will get 0. Similarly, dou u by dou y at 0 comma 0. This also you will get 0. And dou v by dou x. Dou v by dou x at 0 comma 0. This also you will get 0. And dou v by dou y at 0 comma 0. This will be also 0. So this, because here both function are given in multiplication, either you can calculate u h comma 0. So here 0 multiplied 0 and here v of x y. If any x and y will become 0, so numerator will be 0. So automatic you will get 0. So this function is satisfying CR equation at z equal to 0. But what about differentiability? We can check here. Because here again z naught is given 0, because we have to check differentiability at z naught z equal to 0. So you can apply limit z tends to 0. And what is given function f of z? Yeah, given function f of z is x power 4, x power 4, y power 5, x square y power 5. I am writing. Yeah, so limit z tends to 0. What is given function? X square into y power 5 into x plus iy. This is f of z. F of 0 is given 0. And here f of z, this divided by x power 4 plus y power 10. So what is formula for differentiability? F of z minus f of z naught divided by z minus z naught. So this is, you can multiply here z. And what is value of z? X plus iy. So here, if you will observe here, because of that they have given x plus iy, so that you can directly cancel out x plus iy. So now limit z tends to 0 means x tending to 0 and y tends to 0, x square into y power 5 divided by x power 4 plus y power 10. So again we can choose different path. Again we can choose here different path. So if you will choose along x-axis, so along all the path you can choose first path along x-axis. Along x-axis y should be what? This will imply y should be 0. So y 0 means again you can get numerator 0. So this you will get limit x tends to 0, 0 by x power 4 plus y is 0. So this also you will get 0. So along y equal to x, along y equal to x square, along y equal to x cube, along all the path you will get limit 0. But in question it is given that we have to prove that function is not differentiable. So I explained one small trick that how to make this denominator is not equal to 0. So we know that in limits, if you remember, if power of numerator is more than denominator, then limit is always 0. If denominator is more, limit is infinite. So we don't want here 0 and infinite. We want any finite value so that we can claim that this function is not differentiable. So how to get limit finite? So what path can be chosen? So this path I told you For what value of x or for what value of y, power of numerator and denominator can be made same. So this is only one possibility. If I will choose path x square equal to y power 5. X square equal to y power 5, then what you will get? Limit y tends to 0. In place of x square, if I will put y power 5, so y power 5, y power 5, y power 10. And here x power 4, x square is y power 4, then x power 4 is y power 10, y power 10. So you will get 2 y power 10. And this equal to what? 1 by 2. So we can say limit does not exist. DNE means does not exist. So fz is not differentiable. Fz is not differentiable at z equal to 0. So third example is given fz equal to mod xy. This is also very easy to calculate. In this question also we have to prove that CR equation satisfied but limit does not exist. So easily you can observe here u of xy. U of xy is what? Under root mod xy. And what is imaginary part of this function? Because there is no I imaginary part. So v of xy is what? 0. And now you can calculate dou u by dou x. Dou u by dou x at h comma 0. Sorry, 0 comma 0. So this equal to limit s tends to 0 u of h comma 0 minus u 0 0 and divided by h. So this equal to, so now some student they might be thinking how you will calculate u 0 0. So this time it's easy function because here u 0 0 is mod xy. If it was rational function, then again problem will be created, but this time this is not given rational function. So here u 0 0 means x is also 0, y is also 0. So you will get 0. So this you will get limit h tends to 0. Limit h tends to 0. UH comma 0 because x component h and y component 0. So you will get 0. This is also 0 by h. So this is 0. Similarly, dou v by dou u by dou I, dou u by dou I is also 0 comma 0. This also you will get 0. So here dou u by dou x 0 comma 0 0, dou u by dou I is also 0. And here imaginary part is 0. So when you will differentiate imaginary part with respect to x and with respect to y, so this also, it will also come out 0. So dou v by dou x at 0 comma 0, this is also 0. And dou v by dou I, dou v by dou I at 0 comma 0, this is also 0. So, so here CR equation is satisfied. Now we can check differentiability of this function. So differentiability is what? Limit z tending to z not 0, because we have to calculate differentiability at z equal to 0. So f dash z not equal to limit z tends to 0, f of z minus f z naught divided by z minus z naught. So this equal to, here we can write x tends to 0, y tends to 0, x is tending to 0, y is tending to 0. F of z is what given? Under root mod xy and divided by z, and z is what? Z is nothing but x plus iy. And z naught is what given? 0. So again, you can claim that this limit does not exist. If I will choose path along x-axis, so along x-axis, what will be y? Along x-axis, y will be 0. So you will get limit x tends to 0. Y 0 means this y into 0, y is 0, then all you will get 0. So you will get 0 numerator and divided by x plus iy, y is 0. So this you will get limit is what? Along x-axis, limit is what? 0. Along y-axis, if I will ask along y-axis, then x will be 0. So again, you are going to get limit 0. So let me check, let me take different. If I will choose path along y equal to x line, y equal to x line means limit y equal to x, I told you we have to choose those path only. If I will put x equal to 0, then y must be 0. If I am saying this y equal to x plus 1 is also allowed, y equal to x plus 1 is not allowed. So only we have to choose those path which is passing through the origin along x-axis 0, y 0. So along y equal to x, what you will get? Limit x tends to 0, x into x. So you will get here under root of x square, because just I want to remind x y equal to x, then you will get mod x square, and x square is already positive quantity, so you can take inside outside the mod, because here if I will put y equal to x, then you will get mod x square. But here mod is what? Mod will make positive also negative, but x square is always positive. So this you can write mod x square and divided by x plus y is also x, so you will get x common, and here you will get 1 plus I. So this equal to limit x tends to 0, and I told because x square and mod x both are same thing, both represent distance from the origin. So this you will not get here x. If any student by mistake under root x square, if he has written x, so here x and x cancel out, you will get 1 by 1 plus I, which is unique and finite. So you can prove that limit exists and function is differentiable. But you keep in mind under root x square is because if I am taking here minus x, then x square will be what? X square, because small minus square is plus. If I am choosing x, then also it will satisfy. So here value of this under root x square, it may or it can be both plus minus x. So this you will write what? Mod x divided by x into 1 plus I. So now you can define mod x. If x is greater than 0, if x is greater than 0, then x and x cancel out, you will get 1 by 1 plus I. But if x greater or equal to 0, if x is less than 0, then x mod x value is minus x. So you will get x cancel out. So you will get minus of 1 by 1 plus I. So this equal to minus of 1 by 1 plus I. So here both, you can say left and right hand derivative both are different. So this function fz is not differentiable. Fz is not differentiable at z equal to 0. Fz is not differentiable at z equal to 0. So last example of this session, fourth example. If I will remove here, if I am choosing fourth problem, only I am choosing here f of z equal to only mod xy. This is very important question, mod xy. So whenever you will take mod xy power 1 by 2, 1 by 3, 1 by 8, anything if you are getting here power fraction, then always this function is not differentiable at z equal to 0. But if you will remove all the fraction, only we have to check at z equal to 0, and here mod xy is given. Then what you can say about its differentiability? Yeah, let's check. So first let me define here fz equal to mod z, mod xy. So you can get here xy if both x greater than 0, y greater than 0, or x is less than 0 and y less than 0. Either this x, y is positive, both are positive or both are negative. And what about minus x, second part minus x, y? If, yeah, just 1 second. So second time you will get if minus xy when if either x1 is less than 0, x less than 0, or y greater than 0, or you can choose y less than 0 or x greater than 0. So finally, this mod xy we can get either plus xy or minus xy. Now, if I will ask you, what is real part of this function? So this is real part. We can, because here imaginary part is 0. So this f of z also you can write. This in place of f of z you can write real part, because real part of this function is also mod xy. So in place of fz you can write here u of xy. If I will ask you what is value of dou u by dou x at 0, 0, so what will be dou u by dou x? So when you will differentiate now, because this is polynomial type, so you can differentiate directly. So what will be dou u by dou x? Either you will get y or minus y, and here x greater than 0, y greater than 0, x greater than 0, and y greater than 0, or is x less than 0 or y greater than 0. So dou u by dou x, we are getting y and minus y. If I will ask what is value of dou u by dou x at 0 comma 0, so when you will put y equal to 0, 0, so we are getting here 0. Similarly, when you will calculate dou u by dou y, so in that time, when you will calculate dou u by dou y, so dou u by dou y will be what? Dou u by dou y at 0 comma 0. First, we can calculate what is dou u by dou y. Differentiate same function with respect to y. Differentiate same function with respect to y. Dou u by dou y will be what? So x you will get, and here minus x. So dou u by dou y at 0 comma 0, and this also you can write x greater than 0 and y is also greater than 0 or both less than 0. And second case you can get x less than 0 or y greater than 0. So what will be dou u by dou y? Dou u by dou y at 0 comma 0. 0 comma 0 means x is also 0, y is also 0. So again you are getting here 0 and 0. So we can get here what? 0. So, and what about imaginary part? Imaginary part of this function is 0. So dou v by dou x also 0 you will get, and dou v by dou y also you will get 0. So all the CR equations, 4 components satisfied at 0 comma 0. But what you can say about differentiability? Does it need to check by definition? No need to check. Why? Because I explained that what additional conditions should be added in CR equation so that we can ensure that function is differentiable. So what was that additional condition? All the 4 partial derivative, it must exist and continuous. So what are the 4 partial derivative? Either you are getting plus y or you are getting minus y, x or minus x. So all the 4 component y minus y, these are polynomial. So these are everywhere continuous and differentiable. So we can say that this function is what? Differentiable at z equal to 0. And this also you can prove by the definition of differentiability. When you will apply limit z tends to 0, f of z minus f of z naught divided by z minus z naught. So by using that also, you can choose any path. Always you will get limit 0. So this function, if mod xy power is nothing, only power unity, so this function is differentiable at z equal to 0. So now I hope your concept of differentiability analyticity is cleared. In next video, I am going to explain if you are having any analytic function, then its real and imaginary part will form orthogonal curve. So what it means? It means if you are having analytic function, so real part and imaginary part both are orthogonal to each other. Thanks and keep watching.